Hello and welcome again on my channel CIS Stories. After our last video was on how we are drilling holes in the ice and was rather explaining the theory of all the variety, this time I just want to show you some videos of how these things are actually happening. So I got the chance to work with some colleagues training for an expedition this summer, just last week out on a lake here in Quebec, and I helped them deploy some devices and drilling holes through the ice, and I was able to shot some footage that I want to show you now. Okay, we start with drilling a hole for ice thickness. That's always the first thing that we're doing on an ice floe because we want to know how thick the ice is we are working on. So here we are assembling the drill and then setting it on the ice, and here we're just using a hand crank for drilling through this ice. This is for training. This is a freshwater lake close to where I currently live, and you see there's quite some water already standing on the ice, so the massive snow load pushes the ice below the water level, so it's good to have some nice rubber boots. So just by turning the hand crank you can get the ice drilled into the ice, and you'll see after a few minutes you will actually break through the ice, and this ice drill is about 1 meter long. So you see that we're just having here an ice thickness of just short of 50 centimeters.
Like cleaning up the instrument, Marie? Are you noting everything or?
Okay, the next thing that we are working on is drilling ice cores. Here you see Martine drilling a core. You see how the core bell is penetrating and penetrating into the ice. Outer ring of drills. Here you can see the cutting bit, and once you are finished you can drop the ice core onto whatever you're using to store it, and you can see here how the individual pieces of the ice are coming out. So now we are going to a bit more serious tools. This is using the fuel powered drill. This is easier to operate with 2 persons, and you see here we're trying to drill a large diameter hole, which is later on going to be used for the deployment of some CS optics equipment. So here you nicely see how the drill is cutting through the ice. It's kind of exhausting to operate with 2 people. It's very loud, it's very exhausting. But what you also see is how the drilling people constantly or regularly lift the drill up from the hole again to get rid of the cuttings and to free the hole. So this is a fairly small hole, so it's easy to keep things going, but when these are deeper holes and thicker ice, then this is a really tough job. Okay, so here we are deploying some optical equipment through the hole that we have just drilled. So it's a cage that is measuring the optical properties of the water underneath the ice, and here my colleagues are testing out their equipment for the expedition. You see everything is powered by a generator making a decent noise, and my colleagues are leaning over the computer to understand the software and the sensors, what they are doing. So the next thing that we're looking at is actually water sampling. So here we're using a very old method of sampling water in or underneath the ice or in the open ocean. This is the so-called miskin bottle, and you see the bottle is tensioned, and then through a certain release mechanism, if this one pin that he just has his hand on is pushed, it releases those top ends of the bottle, and the water is enclosed in the bottle. And well, here you see it operated. You see that they fix the weight, which we call the messenger, on the line. It gets dropped through, then it hits this bolt and releases the bottle. The ends close, and then you can actually retrieve this bottle. This is another version of this kind of bottle. This has a flotation, so it causes the bottle to immediately close just below the surface. So you see now it comes back up, the ends are closed, and you can take the water samples that you need. And with that, I want to thank you again for watching this video, and stay tuned. Have a nice day.